Okay, now we want to talk about polar curves, polar functions, essentially. Okay, so in polar functions, it's a function with two variable, which is theta, right? First, r and theta. Okay. Of course, we can say r is, if you can isolate r as a function of the rotation of theta. So let's do a very simple example. What if I said, draw the function, the polar function r is equal to 2. That means the radius is fixed at 2. Okay. So when it's 0 degrees, it's 2. When it's pi over 2 degrees, it's still 2. No matter where you are in the rotation, we are 2. Right? If you rotate up, it's still got to be exactly 2, 2. So I hope you can see, right? That means it's going to be, right? It's going to be a circle. Okay, so r equals the radius is equal to 2 at any degree rotation means it's a circle with a radius of 2. This is an example where I fixed the radius. What if I fix the angle? What if I said theta is equal to, let's say, pi over 3? What kind of graph would that be? So the angle is fixed, but the radius is not. Okay, so the angle is pi over 3, 60 degrees, right? Roughly looks like this. But the radius can be anything. So really, we're talking about a line, right? Any point on this line, right, abides by the fact that the angle, right, is pi over 3. Points here, okay, all the points here is when the radius is positive. Of course, if you're right on the origin, the radius is 0. All the points here, you can still say the angle is pi over 3, except the only difference is the radius will be negative. Okay? So in the next video, we'll do something that we don't actually fix either the radius or the angle.